What's up, everyone? So, as you can, well, you can't see my clock on my computer, but it is literally 30 seconds after I just kicked you out of my live session. So if you attended today in my live session, thank you so much. Inevitably, some people are going to jump in there and not see me in there and freak out. So I should probably cue that one back up. So I'll cue it back up really quick just in case someone jumps in, so that they know, that I'm not there. But I could not load PowerPoint. Every time I tried to load this exact PowerPoint right here into Blackboard today, it was kicking me out. And a couple of you got to see that at the beginning. So I'm going to send out a support ticket today. We'll get it figured out. Don't worry about that. I'm going to keep this open so I can kick people out. Recording. Watch this. Oh, yeah, you can't see this. I don't know why. Recording coming soon. All right, there you go. So now they know. Now they know that I'm recording. So here we go. All right. So this is the PowerPoint today. We're talking about errors. We're talking about bugs, and this will go by a lot faster when you guys are not in class, obviously, because there's no one here to participate with me, which is not fun. So you won't get to do all the the fun stuff, unfortunately. But so let's talk about computer science. Let's talk about errors. Let's talk about bugs, and how to identify what type of bugs you're dealing with. All right. So while you're debugging and while you're having, your program crashes or your program doesn't run or it runs in a way that you didn't want it to run, you have to be able to identify the enemy to figure out how you're going to tackle it and what changes you need to make to your code. All right. So it is tolerance week, which I thought was cool. I was going to talk about that, and just neat, but we won't get to do that live, but hey, let me know what you're doing in the email. That's cool. So let's keep looking. So here is slide number 2, and I'm gonna have to figure out how to work through these on OBS Studio. So hold on one second. All right, so we don't have to do our moment of silence. We don't have to do our our quote of the day or our Blackboard rule of the day. But so 2 programmers are always better than 1, right? This is not true. Okay, so this is something we were going to talk about. It's not true at all. So 2 programmers working on the same, when it comes to debugging, trust me when I say that working by yourself is better. Okay, it's better to work by yourself whenever you're debugging, and then move it to another programmer and have him or her work by themselves as well. So that's going to be way more productive than 2 programmers working together. There's kind of an unspoken rule, at least where I have always worked, where 2 programmers looking at a piece of code trying to debug it is never a good thing. So some of us have heard of like rubber duck debugging before, or rubber duck programming, which I practice myself. Where you talk to something on your desk. Remember, usually a rubber duck is much smarter than your fellow programmer. And then be yourself. Everyone else has already taken. Good little inspirational quote of the day. So, all right. So command prompt does not run Python programs. So this is not part of the lesson today. This is just me highlighting this part. So anyway, that's going to be a fun interruption throughout this class. But command prompt does not run Python programs. Remember, there's command lines, and then there's the Python IDLE. Okay, so those are the 2 completely different things. And I want to make sure that you guys know what that is. So if you want to do a little activity to prove this to yourself and to me, go to your computer, go to your Windows search bar, type in CMD to open up a blank command line, and type in pretty much any Python function or Python line of code. So for example, typing in from turtle import everything, and then press enter and see what happens. It will not import the turtle. Okay, so make sure that this is something that you're not mixing up. A command line is very, very different than an IDLE. Okay, so just don't get those confused. We had a couple people get those confused. So the Georgia Standard of the day is all about developing hypotheses and questions about data. So how to look at data and develop some kind of, I don't know, predictions or, really just predictions or conclusions about data just by looking at it. And so that's something that we have to do a lot of in computer science. During the second semester, we're going to get more into data and data manipulation and things like that. But for now, we just want you to start looking at data. Now, when we're talking about data, we're talking about numbers. We're talking about statistics, information that we've gathered from other people, okay? So, what I was going to have you do is have you look at this data and see if you can make some assumptions just by looking at this chart. So we have the sugar consumption in Iceland in, is it 1,000 grams per person per year or something like that. So obviously since 1703 or 1784, really that's kind of when the data starts, the sugar consumption in Iceland per person has gone up very quickly and significantly, up to, you know, close to anywhere from 50 to 60,000 grams per year per person, right? But some of the things about this chart are kind of strange. You can start to notice some things like, I didn't even know there was a laser pointer. How cool is that? Look, so you're noticing some things like this weird gap. So for some reason they chose to break apart the chart here. They chose to start with 1703 and 1784 for some reason, even though there was it was either no data or there was no sugar consumption. In 1800, obviously it looks like that's whenever they started either producing sugar. So these are hypotheses. These are things that we can gather based off this data. Now, we can't prove these things based off this data. The only thing that we can prove is what the data shows us, right? Which is that it was somewhere around 20,000 grams or 20,000 grams per year per person from 1901 to 1905. That's the only thing that we can prove. We can only prove what the data shows us. But we can come up with some hypotheses, or we can come up with some conclusions. Something happened between 1965 through 1980. Something happened here that caused a decline in sugar. All right, we don't know what that was. It could have been a population decrease. It could have been government initiatives to lower sugar, or to higher, to raise sugar costs, so consumers weren't buying as much sugar or consuming as much sugar. Also, huge spike right here. Look at this. Big spike in 86 to 90. That 4-year period, people ate more sugar. Now, again, could be an increase in population. Well, no, I mean, it's really per person, right? So it's grams per person. So really, population may not have as big of an effect on this. But I don't know. Could be people have more money. It could have been, I don't know. What leads to sugar consumption? People could have been more sad. Maybe that's so like I said, there are some things that we could gather based on this, but we can't definitively prove anything from this chart other than what the chart shows us. So we've spent a lot of time on this slide, so let's keep moving. And then this is just another representation of data. This is it's not, we tend to think about charts, we tend to think about graphs and stuff, but that's not always the case. Sometimes we have data that looks like this. I mean, this is still data. It's just, it's just different data. Again, we're talking about sugar, but we're just talking about how much sugar is in each of these items, and this could be some eye-opening data. So this is one I would challenge you. I would challenge you to see, are there any conclusions that you can make based off this this bit of data? Now, it's harder, and this data is not as scalable as the one before. We talked about scalability previously in the year, but see if you can make some assumptions on this, so you can tell how hard it is to do these recordings without like you guys in between to distract me and give me some give me some good feedback. But remember, you can always send that to my email, so send it to my email. So what is the most useful function we've learned this year? This is obviously meant to be interactive by you, so go ahead and put in your results now. All right, nice job. And inevitably, all of you hopefully got that right. All right, so D, input. So the input function in Python is the most useful thing we've got for gathering data this year. If you want to get something from your user, we run something called an input function, okay? And then we can assign whatever they give us to a variable name. We've done that a couple times with like pen color and width and all kinds of cool stuff, right? So this is a very, very useful function for gathering data. So enough about data. Let's talk about errors. Let's talk about these things called bugs. So we've talked about bugs this year. We know what debugging is. We know why we're called bugs, right? We learned that earlier in the year. But how do we identify these bugs as different types, all right? How do we figure out what these types of bugs are, okay? So there's a couple of them. There's a couple of them we're going to learn about today. This is not all of them, but this is most of them. So the first one I want to talk about is a syntax error. This is the big one. Okay, this is the big one. This is the most common error. Okay, so these are your spelling errors. These are, naming a variable, giving a variable the wrong type of name. These are spelling errors, punctuation errors. These are the ones that every single programmer makes, no matter how long you program. I promise. I've been doing it for 20 years, okay? Not revealing anything about my age, but I've been programming for 20 years, and I still make syntax errors all the time, okay? Now, the good thing is, because syntax errors are so prevalent, there's a lot of programs out there that will actually do this for you. They'll scan your code, they'll find syntax errors, and they'll be like, hey, did you mean to write hello with one L? So very, very, very annoying. They're everywhere, but you can, they're also pretty easy to fix. These are the first errors that we're typically looking for as programmers. They're the ones that we look at first, and they're typically the easiest to fix, all right? It's just finding, differences in our code. So, all right, let me answer a quick question on the Blackboard. See, I've got students still in here. Okay, so let's get back to it. So, again, I'm going to give you a little bit of an interactive thing here. How many errors can you spot? I'll leave this on the screen for just a second while I respond to some of these students so that you can look through this. And tell me if any of this stuff, if you can see any of these errors. Now, the errors that are presented on this slide right here are all syntax errors. Okay, they're like I said, it's missing punctuation, things and things like that. So take a look at this for just a minute. Right, cool, happy student. So now let's keep going. All right. So hopefully you found some of the errors. I can see two really quick. There's a couple other ones, but for example, right here, you're missing the asterisks. All right, or you're missing the specific function that you wanted to import. Okay, so you can't just do from turtle import nothing. You have to put something, right? And then right here, look at your parentheses. Print function to, remember, if you have an open parentheses, you have to have a closed parentheses. Same thing with quotation marks. You have to have both of them. All right, so these are examples of syntax errors. So, more interactivity. Which face do you make whenever you're frustrated? These are all kind of the same in my opinion, but I mean, I'm kind of more of a blank stare guy like this. Now, annoyed is the word that I used here for a good reason, because the next two types of bugs are the most annoying. So these two types of bugs are very annoying, okay? For one reason, all right? Because these two errors still allow your programs to run, okay? So whereas syntax errors will not allow your programs to run, all right? They won't crash your programs, but they won't allow them to run. Conceptual bugs and input errors, your program will still run. They just don't run the right way, which is really frustrating because you as a programmer can easily overlook these by running your program and saying, hey, it works, no problem. But it's not working the right way. So a conceptual bug, it says it's overlooked by the program. The program is not working in the way that you want it. Okay, so for example, let's say that you had a program that would keep track of how many apples you eat in a day, right? And so every day you're eating apples, and once you eat the apple, you hit a button and it adds 1 to your total, okay? Well, maybe instead of 1, you have float pointed that variable and it adds 1.0 or so 1.1, okay? I'm just pulling this out of a hat. So let's say it adds 1.1, but you don't notice that it's not, it's not giving you the decimal because you're outputting a round number. Well, what's going to happen whenever you eat 10 apples? It's going to go from being 10 apples. It's going to go from being 9.9 to 10.10, which is 11. So you're going to end up having an extra apple. So the program will keep running. It'll work. You may never notice this happening, but the conceptual bug is there and it's running wrong. So these can be very frustrating and very annoying for programmers because they're easy to overlook. Input errors are usually an error by the user. Sometimes it's an error by the programmer, but it's when you put the wrong value into something. So let's say you're asking the user to determine the color and they put in a number, okay? There are ways as programmers that we can get around that we can give the user like a little shock and be like, hey, no, I asked for a string. But if you don't, it'll often crash the program. And some of you, I've noticed that about your programs. Shout out to one programmer, one of my programmers in this class. I won't tell you who it is, but one of my programmers in this class has actually put alert messages into his programs that would tell me, like I'd type in, 6 for define pen color, and it gave me a little zap, and it was like, nope, you have to put a color name. So that was kind of cool. So shout out to you. You know who you are. So a quick video. We won't look at that. So now let's look at two other types of bugs, and these are the evil bugs. These are, and I'm putting these in categories so you guys can remember them for your exams. But so some are just downright evil. So there are bugs in programming that are just downright bad, and evil bugs do evil things. Okay, and so there's something called a logic bug. All right, now a logic bug is anything that disrupts your program's flow. Now, if you've been paying attention this year, you know that program flow are the things that we use like for loops for, right? So it's how we determine what line of code we want to run and what order we want it to run in. Okay, so we're controlling the flow of our program. Logic bugs disrupt this program flow. And the problem is, in the case of some logic bugs, like an endless loop, for example, meaning a loop that just runs forever and ever and ever, it will crash your computer. So most of the time it will crash, it will freeze everything, okay? And the frustrating thing about Python is there's not a lot of ways to get out of a frozen window. Sometimes you can go through Task Manager and things like that, but often it will result in either your computer locking up, locking down, freezing, and then you have to reset it, which is really frustrating. So be careful about logic bugs. Resource errors are another type. Trying to use something you don't have, all right? So for example, if you try to use a variable, so let's say I tried to use the variable pair, but I had not defined that variable yet. It's not in my program. Well, Python or your computer in the IDLE is going to look for it, but it's going to freak out because it's not there. It doesn't know where it is. So it's just going to keep looking, and inevitably your program's not going to run. Now the good news is with resource errors, often good debugging programs and good IDLEs will catch these. So they will actually catch resource errors just like they do syntax errors, but they're a little bit different than a syntax error, so I want to make sure that you know. Misspelling a variable is a little bit different than using a variable that you've never even created, okay? So it's called a resource error. All right. And so, like I said, here's some, this is the blue screen of death. If you guys have never seen the blue screen of death, this is cool. And then this is like a lock screen. I think this is usually used with Linux or Mac, kind of similar to the blue screen of death. This is what happens when you have really bad logic bugs. So this is probably not going to happen with an endless loop, but really bad logic bugs, you might see something like this, okay? All right, so 2 challenges for today, and I'm keeping this under 20 minutes, so that's good. I'm trying to do this as fast as I can. I know it's a lot more fun when you guys are in here and you guys are kind of interacting with me. So if you have any questions, please send them to my email. That would make me feel better about the recording and all the stuff we're going through. So 2 really quick challenges. So one is a little bit more challenging than the other. This one is what I would consider the easier challenge. So find images or examples of all the following. So take a look at these 5 types of errors, these 5 types of bugs that you might find inside of your code. And just do some research. Go type them into Google. Maybe play around with the IDLE, see if you can create some of these. But get you a reference. Get you some kind of something that would help you remember them because, and this is kind of the big announcement, 15 questions on your interim assessment, 15 questions on your final have to do with errors. That's a lot. I mean, 15 out of, I don't know if let's say there's 50 questions. That's huge, all right? That's like, 30 points on your final. So make sure you really, really know these errors. And then the second one, what I would consider more challenging, would be to try to make these happen. So sometimes it's harder to make these happen. It's easier, you just kind of stumble across them while you're programming. But try creating all of these errors, okay? So actually, what's kind of fun too is see if you can create a file, a Python file that will still run, but that shows all the users or somebody else an example of each one of these errors. And if you can do that and you can send it to me, I'll send it out to your classmates. I'll give you a plug. It'll be kind of cool. So see if you can create a Python file that has one of each of these bugs and put a comment under it. It could be a cool little side project if you guys get bored. Some of you asked me for more challenging stuff. There you go. That would be really challenging. But I'd like to see it happen. So the last slide is obviously that we had some special breakout rooms and stuff. But let's talk about the ticket out the door is zombie. I don't know what the inspiration for this one was, but some of you gave me some heck about this one, so it wasn't as creative. So I'm sorry. Next week I'll come up with something better. So there's your ticket out the door password. Thank you guys for. I know it's hard to sit through a 20-minute recording of just me talking. Trust me, it's hard for me to do it too. But thank you guys for watching. I'll try to get this issue worked out by next week, and we'll be back in live class and we'll be able to interact with each other. So, but thank you guys for watching. If you have any questions about any of this material, just send them my way, and I have plenty of time tomorrow for breakout sessions or learning conferences. So just let me know if you guys need anything. Good luck with the end of the semester, and I'll talk with you soon. Bye.